Something that we learned about this semester that we thought was really interesting and we wanted to learn more about its applications is the Magnus effect. We'll start off with a little example of what this is.
Go ahead.
If I flick this pen, you can see it behaves as you would expect. It goes forward a little bit and falls to the ground. But if
Or
instead we put a backward spin on the pen, you can see that it glides through the air as it goes forward.
or
We'll watch that one more time so you can see it.
So because the tube is spinning in this direction, the flow is going further over this way and the velocity is higher. As such, the pressure is lower here. And then on this other side, because it's resisting the motion of the tube, the velocity is lower, therefore the pressure is higher. And this pressure gradient essentially generates lift in the upward direction, which is what makes the tube kind of float in midair and not fall, as you see when we just push it off the table.
One application of the Magnus effect that has been tested is replacing the wings of an airplane with rotating cylinders. So as the airplane moves forward into the wind, you get that same difference in pressure on the top and bottom of the cylinder, and this can generate lift for the airplane. It's been tested in a few different scenarios on big scales like you can see in this picture, as well as in small drones. Um, there's more refinement that needs to happen for it to be able to be adopted on a large scale. Another really interesting application that we learned about of the Magnus effect is in external ballistics. So when a bullet is fired, it has a rotation about its axis, and if there's a crosswind, it can either cause a force to pull the bullet up or to push the bullet down to the ground. So this is an important consideration to take into account for long-range shots in high wind. Um, Professional snipers need to be able to take into account the crosswinds and what effects it will have in pulling that bullet up or down. A third interesting application that we learned about is using what are called Fluttner rotors on ships. So as you can see in this image, there are 4 vertical cylinders, and these would be rotating as the ship is moving. And the idea is it works similar to a sail on a boat. So if there's a crosswind coming, um, basically that has any perpendicular component compared to the direction of the ship, it can be used to propel the ship forward by rotating these cylinders and generating a difference in pressure through the Magnus effect on these cylinders. And then the ship can be steered to take the component of that force that is in the direction that the ship wants to go. At this point, it is something that doesn't generate enough force on its own to propel the ship, but it can be used to assist in propelling a ship, and it's being researched right now as a method of propelling a ship using less energy. Thanks for watching. Here are some of the sources that helped us learn more about applications of the Magnus effect.